first session of Godot game programming. I'll introduce how to do the programming, the basic functions, basic movements, and some instancing works. So Godot is a game engine that is relatively new, and it supports iOS and Android environment, as well as Windows, Linux, and Mac OS native folks. And I see the Godot engine has been released to 3.1 version, and now I'm testing is 3.1 Alpha Mono Official, which is also supports various languages. There are a few languages nowadays Godot engine supports. The first one is the GDScript, Godot script. The Godot script is made by itself, and it has an inbuilt IDE to support it. And the new 3.1 Alpha Mono official version nowadays supports C#. So anyone, if you are interested in game programming or you know how to build C#, you can have it a try. It is a great alternative to Godot 2DX because it is cross-platform, and it also has good code and IDE supported. But the drawback, and I didn't think of any drawbacks, but the most significant drawback is that the Godot engine is still in rapid development. That means that it is not as stable as you think. But I first tried it Godot engine version 1 3 years ago. At that point, it is relatively much less stable than as it is now. So I think this time it is a relatively suitable time for me to have it to drill, and I am still learning Godot engine nowadays, and it's relatively new. But in order to make it more popular, I would like to have a tutorial to introduce how this works. If you are building 2D engines or 2D games, etc., it is a very good alternative if you used to use Unity, because it is totally free. It is totally free, yes, totally free. It's the most important aspect. So it's not only totally free, but it is also totally open source. There are hundreds of contributors. One of them is me, and I'm also the contributors and the donators, because I think the world has to deserve one that has a free environment as well as a fully fledged IDE. As you can see, it also supports 3D game development, but for now we focus on 2D tutorial development. So let's see. I'm going to import the .ss, these SS. You can download this .ss inside this one. You go to Godot Engines, the Getting Started tutorial, and then you click your first game, and then you will find this one, download.ss.zip. You click on it, and then you will download all the SS I'm going to introduce. So this is the basic, and you have to read this because these are very important ones that will introduce you to the whole development, the basics. Right, so I'm going to copy these Dodge assets into the project folder. When I do that, Godot will automatically scan all the Dodge assets, and you see it's already here. So automatically it consumes all the files, and I can directly use them. So how to start? Okay. First of all, we try to create a main scene here, and so it's a main scene. So and then the second steps is to set a project, set our screen size. We should set it project display window, and I can set the size here. I would like it to be horizontal, or I would like to be supported iPhone size, so not resizable, not borders, not full screen, not horizontal. That's okay. So it's good. So I close it. That's it. Then you'll see this is the main screen. The second thing I'll directly drill into creating a player. I'll create a player character here. I'll click here to add a new scene, and then root node always is a 2D node, and I would like to give it a name as a player. So there's the player node. So I would like to give it an image and try to put some animations to it by coding. I would like to create a character which can move up, down, left, and right. So I would like to give it an animated sprite as the player's child node by right-clicking on player and add child node sprite, and you find animated sprite. So we have just created an animated sprite. And for the Godot 3.1 nature, if any node configuration is incomplete, it will show a triangular warning here. So let me click on it. It will show the warning here. It's a very convenient way for us beginners. YC of sprite frames resource must be created or set in the frames property in order for animated sprites to display frames. So well, don't be afraid, it is the essential steps here. Animated sprite frames, empty. We click on it, and we click new sprite frames. We click on it again, and we open editor. So we find the player, the 4 player grade, 1, 2, 3, 4. We drag them over here, and we will see 4 of them. Okay, then that's not all. You see this unsaved. Let me save it first. Save scene player.tscn. You click save, and that's it. And I can show you more about it. Player, you can transform here. You see, the character is actually moving. And you can make it rotate here, and you can scale back or down here, and animated sprite. It can also be changed. Yes. Transform scale 0.5, 0.5. Both player and animated sprite can change the scale, but I would like to do the collision introduction here. Collision shape 2D, create, and here we see the no configuration warning here. Basically, it tells you to select a shape. So look at the cursor here, collision shape 2D. We click on this empty space. We will select new capsule shape 2D. So what does that mean? That means that this player will be able to interact with other players or other enemies or other bullets, hit points, and how do they react, and how do we judge the collision between different objects? We'll rely on this one, collision shape 2D. So after set it complete, that's it. Okay. We will talk about collision shape 2D in our second episode. The first episode I would like to introduce is movements. We should focus on movements for now. We will click on this player node, and we attach a new description sheet for the selected node by clicking this button. So language, as you see, you can even select C#. If you're familiar with it, you can give it a try. And we'll stick on GDScript because it supports more, and we support auto completion relatively more because C# is still on the experimental shape. So I'd like to go for the GDScript and create a new script here. Extends node 2D. So I'll create a few variables here, and then I will create the ready script to set the universal stage. So as you see, this ready and process. This function will be run when the game starts, and this one will be always repeatedly run by until the time. So I would like to have a speed variables for us to be set inside the inspector. I'll show you how it's done. If you're familiar with Unity, you'll get my point. First of all, I will say export variable, export variable speed integer. So what does that mean? It will export a speed variable for us to be set. When I left click on this player again, you'll see speed here. I can set it to 150, and after I set it to 150, that implies that this speed variable will have an initial value of 150. If you set it later on to be bigger than 150, its movement speed will be higher, and you can always change it. So I would like to demonstrate how to get the screen size here. I would like to set the screen size as the player's playground. So I will have a variable screen size vector 2. Vector 2 is a type. Is a unique type of Godot which is equivalent to Unity's vector 2D, vector 3D, etc. You know what I mean. So I will initiate screen size variable is get wheel port red dot size. Okay, and you can get the screen size width and height by x and y, because vector 2 is new vector 2 of x. That's also valid. So there's a important global function for the player. Global variable default is position. Position means the player's this node's position. We can always set it by code. Position, for example, position dot x is equals to screen size dot x divided by 2. Position dot y equals screen size dot y divided by 2. The meaning is we just set the node's position into the center of the screen successfully. So we have just completed the ready function, and then in the process function we would like to have it to support some input entities. I would like to introduce input dot action action what I've just forgot. Okay. Input is action pressed. So we have 3 actions. Is action just pressed it, just released it, is pressed it? What does that mean? Just pressed it means I just hit the keyboard. That's all. It will be enacted once, and it's just released. That means when my finger leaves the key, that means one is down and one is up. And how about this? Is action pressed means that the only variable situation, the only situation that is between up and down. That means I just hold the down key. I just hold it and didn't put it back up. So one is begin, and this one is continue, and this one is release the key. So I will use this one, and then press UI left, and I will repeat it again with a more elaborate sense. I would like to use if for ifs. What does that mean? It means I have to consume all the up, down, left, right if conditions with if. Input dot is action pressed UI left. Okay. In Godot's world, we also have a global variable for the nodes to use, that is velocity. I would like to introduce velocity. For example, if I click left, velocity x is -1. If input is action pressed UI right, velocity dot x 1. If input is action pressed UI down, velocity dot y +1. If input is action pressed UI up, velocity by -1. We just completed the mapping here. So I would like to also introduce the animations for him by checking if we have utilized its velocity growth function. If velocity dot length be bigger than 0, velocity dot length bigger than 0, that means we have just set the velocity here or here, either one. It will make the velocity's length bigger than 0 because we have input some kind of data into it. So velocity dot velocity dot normalized speed. Okay. Oh, sorry. To here, right? Sorry. Speed. Okay, that's it. So there's a global variable here, animated script. Dot play. Else animated sprite dot stop. Okay, easy. The next thing is we set the position directly. Position equals velocity multiplied by delta time, and then we'll set the boundaries of the player's position to prevent it to get out of our screen or leave our game completely here. Left, sorry, clamp, position of x 0, screen size of x, position of y equals clamp, position of y 0, screen size of y. So let's try. At this point we can just try to test the game. We click here, go back to the main screen here, and we'll use this one to instance our player here. Okay, main player. That's it. We can just test it. No main string has ever been defined 7. Okay, with that main. Double click on it and we'll start debug process. Start. Okay. It just starts moving. Good. And we click here to start the debugging. Okay, player, and we click this to go back to our script here. So, we'll do something to do our animation. First, we click on the animated sprite, and we click on the frames here. Open editor, and here's the default animation. We'll start an animation which is right. Here is a up. Okay. We'll put these two. Oh, sorry. These two means up. This right. We'll put it here. Means it points to right. So we have just created the right and up animation successfully. But how do we use it? We use the code here. We just get back to here and we write animators right, animation equals right, animated right or animation equals up. Okay. And how about flipping the directions? We would like to see down and left. How about left and right? Left and down. We can add this and just write flip h is equal to -1 or 1. Okay. It basically it can be a boolean. I will try to demonstrate it here. Velocity dot x if is bigger than 0, that means it's okay. Flip y equals flip v. V means vertical, h means horizontal. So we have just successfully made it. What does that mean? Flip h if the velocity x is less than 0, then flip h will be equal to 1. If velocity x is bigger than 0, then flip.h will be -1. If flip h equals 1, that will be a normal sprite. If flip.h equals -1, that will be flip upside down. You know what I mean? Just a mirror flip. So let's have a final touch here. If velocity dot x does not equal 0, animator's right animation is equal to right, animator's right flip h is equal to velocity x. You know what I mean. Else if is ERIF y equals 0 will add this. That's it. Let's go back to the main script and play again. Up, down, left, right. You know what I mean? So, did you achieve the same result as mine? If yes, then let's continue to our session 2. In indefinite time, I will announce the next session to demonstrate the Godot engine usage and to demonstrate the collision steps. We also have these enemies. Enemy flying, enemy swimming and walking, and we'll demonstrate how to spawn the enemies to attack the player and how we dodge the enemies. So that's complete. See you.